Hi everyone, welcome to this lecture. I am Ravikumar, Department of Chemistry, KSRCAS. Today's video we see the topic about periodic trends. Before that, we are going to discuss about electronic configuration of elements. So the basis of electronic configuration, the elements are classified into 4 groups. So the first one S block elements, second one B block elements, third one D block elements, and then final one F block elements. So the first one S block elements. In S block elements, the last electron entered into S orbital is known as S block elements. Usually S orbitals can accommodate a maximum 2 electrons. 1A group elements are also known as alkali metals because the alkali metals react with water to form alkalis. And then second one, second A group elements are also known as alkaline earth metals because their oxides react with water to form alkalis. And then total number of S block elements are around 14 elements. So group 1 alkali metals, hydrogen, lithium, sodium, potassium, rubidium, and then cesium, francium. Group 2 alkaline earth metals are beryllium, magnesium, calcium, strontium, barium, and then radium. B block elements. Here also the last electrons entered into B orbital, so it is called B block elements. So B subshell can accommodate maximum 6 electrons in orbitals. So B block elements are divided into 6 groups, which are 3A, 4A, 5A, 6A, 7A, and 0 groups. The total number of B block elements in the periodic table is around 30. D block elements, here also the last electrons entered into D orbital, so it is called D block elements. So all of these are metals. In D block elements lies between S block and B block. Out of the all D block elements, mercury is the only liquid in D block elements. So the next one, F block elements. So the elements from atomic number 58 to 71 are called lanthanide because they came from after lanthanum. The atomic number of lanthanum is 57. The elements from 90 to 103 are called actinides because they came after actinium. The atomic number of actinium is 89. So usually lanthanides occurs in nature in low abundance. So it is called rare earth metals. Okay. All the actinides are radioactive elements. So the next one, periodicity. So periodicity means the regular gradation in properties from top to bottom in a group and from left to right in a period is called periodicity in properties. In a period, the ultimate orbit remains same, but the number of electrons gradually increases. In a group, the number of electrons in the ultimate orbit remains same, but the value of n increases. Here the n denotes the principal quantum numbers. Atomic radius. So atomic radius means the average distance of valence electron from nucleus is called atomic radius. It is very difficult to measure the atomic radius. So the reason is the atomic radius is because the isolation of single atom is difficult. No well defined boundary for the atom. So the accurate definition of atomic radius is half the internuclear distance between two atoms in a homoatomic molecule known as atomic radius. Based on this chemical bond, the atomic radius is divided into 4 categories. So first one, covalent radius, second one ionic radius, third one metallic radius, and then fourth one van der Waals radius. So first one, covalent radius. Covalent radius is the half of the internuclear distance between two singly bonded homoatom. For example, if we take chloride molecule, the internuclear distance is 1.98 angstrom. So 1.98 divided by 2, we get the value of 0.99 angstrom. So 0.99 angstrom is the effective atomic radius of a chlorine atom. Ionic radius. In ionic radius, first we discuss about cationic radius. When a neutral atom loses electron, it converts into cations. Cation means positively charged ions. So cationic radius is always smaller than atomic radius. For example, if we take lead 2 plus and then lead 4 plus, lead 2 plus atomic radius is higher compared to lead 4 plus. If we see another one example, iron, Fe3 plus atomic radius is very low compared to Fe2 plus and then iron. So the next one, anionic radius. When a neutral molecules gain electrons, it converts into anion. Anion means negatively charged ion. So usually anionic radius is always greater than a parent atom. Reason, effective nuclear charge. Usually the effective nuclear charge is very low, means its atomic radius is very high. If we take fluorine atom, fluorine and then fluoride. So the atomic number is 9 for fluorine and 1 electron more in fluoride. So Z by E ratio is, if we applied for fluorine, so 9 by 9 we get 1. In the same way, if we applied for fluoride, 9 by 10 we get the value of 0.9. So the effective nuclear charge value for fluoride is 0.9. Already we seen which one is low effective nuclear charge, means it get higher atomic radius. So in the similar way, fluoride is low effective nuclear charge, so it is more atomic radius compared to fluorine. So the next one, size of isoelectronic species. If we take some example for isoelectronic species, isoelectronics means same electron but different nuclear charges. For example, potassium K plus and then calcium 2 plus, sulfide and then chloride. In this example, the electronic count is 18 for all the elements, but the atomic number is different. So if we apply Z by E ratio, Z denotes the atomic number, E denotes the number of electrons. For example, potassium plus, the atomic number is 19, so the number of electron is 18. So 19 divided by 18, we get the value of 1.05. In the same way, calcium 2 plus, so the atomic number is 20 and the number of electron is 18. So 20 divided by 18, we get the value of 1.11. In the same way, sulfide and then chloride also applied. In chloride, the atomic number is 17, the number of electron is 18. So 17 divided by 18, we get the value of 0.94. In the same way, sulfide, 16 divided by 18, we get the value of 0.88. Effective nuclear charges value for sulfide is 0.88. So in the similar way, effective nuclear charge is very low for sulfide, so it have a more atomic radius value. Trends in atomic and ionic size. If we take group 1 elements, for example, lithium, sodium, potassium, it loses 1 electrons and converted into its cations, like lithium plus, sodium plus and then potassium plus. So the picometer value of lithium is 152 and then lithium plus is 60. So lithium plus value is very low compared to its parent ion. In the similar way, sodium Na plus value is 95 picometer, sodium atom value is 185 picometer. Actually, the 1 picometer is equal to 0.01 angstrom. So the metallic radius, half of the internuclear distance between two adjacent metallic atom in crystalline lattice structure. Usually metallic radius is always greater than covalent radius, because in covalent radius the orbitals overlapping is occurred. In metallic radius there is no overlapping occurred. So factors affecting the atomic size are: first one, effective nuclear charges. Always we discussed a lot. Effective nuclear charges increases, the atomic radius decreases. For example, lithium, beryllium, boron, carbon, nitrogen, oxygen and then fluorine. In beryllium, effective nuclear charge is very high compared to lithium. So lithium atomic radius is higher compared to beryllium. Second one, number of cells increases. So the number of cells increases means the atomic radius also increases. For example, if we take alkali metals, hydrogen, lithium, sodium, potassium, rubidium and then cesium. Cesium atomic number is very higher compared to rubidium. Also its cells also increases. Okay, so cesium gets higher atomic radius value. Almost the screening effect value increases means the atomic radius value almost increases. So the next one, a magnitude of negative ions. So the negative ions almost increase the atomic radius. And then final one, magnitude of positive ions. So positive ions increases, the atomic radius value is decreases. For example, if we take manganese 4 plus atomic radius is very low compared to manganese and then manganese 2 plus. Okay, for example, Mn 4 plus and then Mn 4 plus atomic radius is very low compared to manganese. Okay, because it loses 4 electrons. In upcoming classes, we will discuss about electronegativity and then electropositivity. Thank you.